This is my lab 5 for Physics 1, SpongeBob colliding with Patrick Star. This is my table of contents. So, the purpose of this lab is to observe an inelastic collision and demonstrate conservation of momentum. Following collision, friction is demonstrated as the system slowly loses kinetic energy. The technology used is Tracker and GlowScript, and the assumptions are that there are no air resistance and there is negligible friction. My expectations are that momentum will be conserved during collision and kinetic energy will decrease. My preview of results is fairly similar results in experiment and simulation, that the velocity decreased after collision, that the momentum remained stagnant, and that outside work or friction caused momentum and energy to diminish. Now, for physics principles, laws, and formulas used, the momentum principle P is mv. The perfectly inelastic collisions equation, m1v1 plus m2v2 is equal to v times n1 plus m2, and the energy principle where delta U is equal to Q minus the work done by the surroundings. So delta U is the change in internal energy, Q is the heat added to the system, and W is the work done by the system, and kinetic energy K is 1 over 2 mv squared. In addition, friction is equal to Un, which is equal to mgu times the coefficient of friction. Velocity and position update formula where Vf is Vi plus F net over m delta t, and Rf is Ri plus V average delta t. Now for the system and the initial conditions, the system is SpongeBob and Patrick Star. The initial velocity is 0.429 meters per second. The initial position of SpongeBob is 0 meters, and that of Patrick Star is 0.1 meters. The mass of SpongeBob is 0.495 kilograms, and Patrick Star's mass is 0.041 kilograms. This is the data from Tracker, where we can see the plot and the table under with all the data that I amassed. Now, for the computational model, some things were edited, like the object's velocity, the object's position, the object's track, the kinetic energy, which was done using the formulas that I used and plugging in my values. This calculates the mass of the cart and now the new velocity. And it would also calculate the coefficient of friction and the force of friction. This is all done using GlowScript. This is more of my code, which shows the visualization, the graphing, and more of the code. This is my result from my GlowScript code. As you can see from this recording, this is my graph of position versus time, and what was above was my video. So these are my graphs from GlowScript. You can see the position versus time graph, the velocity versus time graph, and the kinetic energy versus time graph. This is my experiment versus modeled positions. So as we can see, the two graphs are fairly similar, extremely similar in the beginning, some would say, and as time goes on, they differ more and more. So the GlowScript versus Tracker. The similarities are that they have the same starting point, the same displacement up to collision, very similar velocity diminishment post-collision, conservation of momentum is present in both as expected, and friction is present in both. Now, for the differences, the model decelerates slightly slower than the experiment, and there's more variation in experiment data. For possible sources of error, could be change observed in velocity, the model fails to account for air resistance, there is human error in tracking, and it could also be a result of camera angle and movement. What does this mean? Is energy conserved throughout the collision? Is energy conserved as friction is applied? So kinetic energy is not conserved during collision. Total energy becomes internal heat as kinetic energy. Kinetic and total energy dissipate when friction is applied. Friction is an external force performing work on the system, and energy extracted from the system becomes external thermal energy. Now, finally, we could ask, what if the collision was elastic? If the collision were to be elastic, momentum and kinetic energy would still be conserved, the objects would have very different velocities, and the shape, temperature, and internal energy would remain unaltered. This is my Lab 5 for Physics 1. Thank you for listening.